Hi everyone, in this video I'm gonna be talking about standing wave thermoacoustic refrigerator. It was my terminal project and I wanted to demonstrate to you guys that what is this standing wave thermoacoustic refrigerator. Firstly, the thermoacoustic refrigerator is of several types. You can build it in several designs, and major two types depending upon the wavelength and the wave is basically standing wave and traveling wave thermoacoustic refrigerator. Further, if we classify it, we can classify it into half wavelength and quarter wavelength thermoacoustic refrigerator. So before dwelling into what is thermoacoustic refrigerator, we should talk about refrigeration. It is simply the removal of heat from the low temperature zone to the high temperature zone, and as it is against the gradient, so some work has to be performed. On the other hand, thermoacoustics is basically the interconversion of heat and pressure oscillation, basically the energy exchange between the heat and pressure oscillations, because both are the form of energy. And by pressure oscillations, I mean sound. Thermoacoustic refrigerator are basically those devices that basically perform this thermoacoustics process, or this thermoacoustic principle is implemented in these thermoacoustic refrigerators. So I prefer thermoacoustic refrigerators instead of vapor compression cycle refrigerators. Basically, firstly, that they use harmful refrigerants. No doubt that green gas refrigerators and other are in play, but the most used are vapor compression refrigerators, which are harmful for the environment. And secondly, these vapor compression refrigerators have abundant moving parts. A lot of moving parts are involved in the vapor compression cycle refrigerators, while in the thermoacoustic refrigerators, except the sound source, there is nothing that has to be moved when talking about standing wave thermoacoustic refrigerators. Phase change does not occur in thermoacoustic refrigerators. In vapor compression cycle refrigerators, it occurs. Now it is a good process. It allows a lot of change of heat. Maximum change of heat occurs by the phase change, where there is no involvement of the change of the temperature, but there happens a change in the state of the fluid that is under the plate. But for the phase change, we want some refrigerants that are toxic and at the same time they are to be volatile and they are not stable, which leads to expensive refrigerants, unlike the thermoacoustic refrigerators in which we can use air or helium or any other noble gas. And secondly, we have to make sure that the phase change occur at the appropriate spots in these vapor compression refrigerators to make it efficient. So these are the components that I use in my project for the formation of thermoacoustic refrigerator that was standing wave type. There was a loudspeaker as a source of sound that was attached to one end of the resonator tube, while the other end of the resonator tube was closed. In the case of the water wavelength thermoacoustic refrigerator, the other end will act as an open end. We will arrange it in such a way, but in my case it was a closed end. The stack is most important component of the thermoacoustic refrigerator. It is the heart of thermoacoustic refrigerator. It is basically a device, or it is basically a geometry that can locally form temperature zone and locally store heat. It is the main reason why the temperature gradient can be formed in a thermoacoustic refrigerator. And then we require a heat exchanger so that from hot side the heat escapes continuously, and from the cool side we can allow the refrigerator as like in evaporator or the vapor compression cycle refrigerator. And this is the cool spot of thermoacoustic refrigerator. From the hot side we will maybe attach an aluminium plug or something like that so that the heat continually escapes. This is the simplified model of a standing wave thermoacoustic refrigerator. Firstly, we want to produce the sound from one end, and the other end will be closed. In the case of the standing wave thermoacoustic refrigerators, that is half length. So we will make sure that the resonance is produced by the appropriate formula used in the thermoacoustic refrigerator, not dwelling into the calculations, simply telling that we will adjust the length in such a way so that the resonance is produced. In this way, there is some hot region produced at this end and the cold region produced at this end that will be due to the stack operation. Now what is the stack operation? pressure and the velocity antinodes will be formed. At some places the pressure will be higher, at the other places the velocity will be higher. At the places where the pressure is higher, velocity will be low. At the places where the velocity is higher, pressure will be low. So there will be consecutive high pressure and low pressure zone that will be established. So the heat, the gas will be pumped at this zone. For example, here there is a pressure node and here there is a pressure, here there is a pressure antinode and here there is a pressure node. So the gas will be compressed at this zone because of high pressure and will be expanded towards low pressure zone. This is the phenomenon that will result continuously, so that the stack operation is evident and the heat is continuously moving towards this hot heat exchanger, and from which it will be continuously removed. So the cold heat exchanger and will act as the corresponding to the evaporator in the vapor compression cycle refrigerator. One of the best example of thermoacoustic refrigerator is by the ice cream storage containers by Ben and Jerry's. They were installed for the ice cream storage and they work very effectively with a high temperature draw. Moreover, US Navy wants to have this installed in their submarines so that the harmful refrigerant leakage are prevented, because if refrigerant leaks into water it will hurt or it will damage and affect the water life.